Hello again, and this time I want to talk about something that's it's a concept that's very important to really understand conceptually. It's easy to show algebraically, but if you can get this conceptually, it really makes working with variances a lot easier. And that is the concept of the variances always add. And what I mean by that is if we do have, for example, let's say we have two random variables, x and y, okay, and they're independent, so I'll stipulate that, okay. And we are taking the variance of the difference between those two. We end up with the sum of the variances. Now, on the surface, that might not really make a whole lot of sense. You might think, why would it be the difference? Well, algebraically, it's quite easy to show. It doesn't really sink it home any deeper in your brain if you show it algebraically, but you can show it. You can just make a simple substitution and say that z equals minus y. And then say, well, okay, then in that case I've got x plus z, the variance of x plus z, which is what we would expect, plus the variance of z. And then when we put the substitution back in, right, then what we would end up seeing would be we would have this, right? Now remember, recall that when we have a variance of a constant times a random variable, say cy, what we end up with is the c comes out squared outside the variance, so we end up with c squared times the variance of y. Okay, that's actually quite easy to show why that has to be the case. I'm not going to spend time doing that here, but just note that. So you can see how now we've got the variance of x plus 1 minus 1 squared times the variance of y. And of course, then now we're done. Now we've just, minus 1 squared is 1. And so, right, that was when we did our substitution back here. It was the sum of the variances. Okay, so, okay, fine algebraically, but still that doesn't really make the concept any easier to understand. Let's try to picture it like this. Let's picture a carton of milk. And it's, say, a half gallon. So it's 2 quarts, okay? And you would agree that the measuring equipment at the milk factory is not going to get it exactly 2 quarts, right? It's going to be a little off. Some containers are going to be 2 quarts plus a little bit. Some are going to be 2 quarts minus a little bit. So let's call the amount of milk in that container, or the amount of milk in any container, of these half-gallon containers, let's just call it x. Now, it's a random variable because it has some variation in it. We don't know exactly how much is in any particular container. Okay, so now what we're going to do is we're going to pour half of it out into this container over here. So we're going to pour half of it out, 1 quart, and we're going to do it by hand. And, well, if I was doing the pouring, even at the best of my abilities, I'm not going to be able to pour out exactly a quart. My pouring skills are a little off, so the amount of milk in this container is going to be, call it y. Again, because, that's going to be, I'm going to be introducing some variance into the amount y. So let's call it y. So now what we want to know is how much do we have left here in the original container? Well, let's see. 2 quarts minus a quart would be a quart, but again, we are a little off, aren't we? We have some variance there. So the question is, what's the variance of that difference? And so that's what we're getting at. What's the variance of the original amount, which had plus or minus, and then we're subtracting a quart that we poured out by hand. So we want the variance of the difference, which was this 1 quart that was left over here, half full, and it had some variance in it. So the question is, what is the variance? Well, okay, put on your thinking caps a little bit. We started out with a certain amount of variance, and when we poured out the amount of milk into the separate container, we introduced another variance to it. We introduced another sort of uncertainty in the carton here. And so what we're left with is the original amount of uncertainty plus the amount of uncertainty that we were pouring out. Now, look at it like this. Let's say that the original quart container had 2 quarts, but it wasn't exact. And let's just say that it was actually a little over 2 quarts. We'll say plus D, some small amount D. Okay. And then when I poured out the container, okay, here's the original container. And when I poured it out, I ended up pouring out 1 quart, but I was a little shy about pouring out a full quart. I was a little off. So it was a quart minus a little bit, minus C, say. Okay, so what are we left with in this case? In this case, what do we have left? Well, we have this, it's a half a quart. But since we were overshooting it, since we overshot it here from the factory, and we undershot it here when we did it by hand, then what we have left is actually a quart plus the over amount here, right? Plus the amount we undershot there, right? Plus C. Since we poured out a little bit less than a quart, we have more left over in the original. So this is what we have. We have this variance here that's added. Now let's look at another extreme case. Let's say, for example, that instead of the carton having 2 quarts plus something, let's say it had 2 quarts, but it was minus a little bit. Let's say it was just a little shy of 2 quarts. And let's say that when we poured it, out, okay, here was our 2 quart thing, and when we poured it out, we were a little bit too aggressive, and we got it 1 quart, well, say plus C. We got a little bit more out, so we actually dumped out a little bit too much from the original one. So what are we left with? Well, we're going to be left with a quart, but what we're going to be left with is we're going to be a little shy of a quart, aren't we? But how much shy? Well, if you think about it, we're going to be shy by the original amount we were shy, and then we're also going to be shy even more than that because we poured out more than a quart. So what we were left with is going to be less, right? So we're now shy of a quart by the same additive property, D plus C. So what you have to realize is that when you're looking at this scenario, you're talking about an infinite number of cartons and making pours of a quart out of it an infinite number of times. And so when you look at it in that sort of broad spectrum, where you have sort of this infinite number of cartons and you're doing this sort of an infinite number of times, it's going to be you're going to be including all the worst case scenarios where you started out with too much and you poured out too little, and you started out with too little and you poured out too much, and everything else in between. So you can see how then, if you look at it from the broad perspective like that, the variance is inclusive of the extreme cases on either end. So the variances add. Anyway, that's pretty much all I want to say at that point. I'm not really sure if there's an easier way of saying it. If you put your head around that and and the light finally comes on, you're going to be that much further ahead, because working with variances from that point forward is going to be a lot easier because you're going to conceptualize how variances work. Anyway, hope you do well in class and have fun. Bye-bye.